In this video, we're going to look at some of the details of quadratics. So one of the details we talk about, one of the things we identify in quadratics is what's called concavity. Concavity. So where is the cave? Where is this opening up towards? And so when you see this one on the left right here, the arrows are pointed up. It is going up. We say that this is concave up. It is going upwards, whereas this one on the right is concave down. Now, when you look at these visually, it's very obvious where it's opening up towards. This one, first one's opening up, the second one's opening down. However, when you look at it in terms of an equation, it's still very easy. And it doesn't matter if it's in the standard form ax squared plus bx plus c, or if it's in vertex form a times x minus h squared plus k. It's the same thing either way. If a is positive in either of these forms, if a is positive, it's going to be concave up. Hopefully it's intuitive then that if a is negative in either of those forms, it's going to be concave down. So how can you tell the concavity? You can either look visually and see which way it's opening up, or you can look at the a term in either form. Positive a means it's going to be concave up, and negative a means it's going to be concave down. The next thing we're going to look at is where these parabolas are increasing or decreasing. Now, this we observe as we look from left to right. So we read from left to right, and so we make these observations from left to right. So despite the fact that both of these sides have arrows pointing up, as we move from left to right, this is actually going down from left to right. It's going down from left to right until it bottoms out at the vertex. So this vertex is at the point -2, +1. So where is this quadratic, this particular parabola, where is it decreasing? Well, it's decreasing if we write an interval notation from -infinity, from the far left, all the way until it hits -2. It is decreasing on that interval. It's going down from left to right on that interval. And it's increasing, starting at -2, all the way to forever. It's increasing. And as you can see right here, as we move from left to right, this is going up. It is going up. So increasing and decreasing. It's always going to change at the vertex. The nature of parabolas is going to change at the vertex. Now, when we look at this concave down parabola, this one on the right, what you'll notice is from left to right, this is actually going up to begin with. So from -infinity all the way to its x-coordinate, which that's at 3. It is increasing. And it once again flattens out just for a moment at the vertex. And then after that, so from 3 to +infinity, it is going back down. It is decreasing. So if you're asked about increasing or decreasing, where is the graph increasing or decreasing? We observe that moving from left to right. And it's typically written in interval notation, and it will always change at the vertex. Lastly, we're going to talk about maximum and minimum values. So when a parabola is concave up, let me erase some of these details here. When a parabola is concave up, it has what's called a minimum value. It bottoms out. It is the lowest point. Now, the highest point, let's be real clear, it goes up forever. It goes up forever. But it does have a minimum value, a place where it bottoms out. And when it asks for the minimum value of a parabola, it is very specifically asking you what then is the y value of the vertex, because the vertex will be the lowest point, that minimum value. So in this case, because it's at the point -2, 1, the minimum value for this parabola is 1. That is the lowest point. Now, when it says value, that specifically is talking about the y value. So you would not put the points -2, 1. -2 is not the value, -2 is the input. We're talking about the output. The lowest value, the minimum output, the minimum y value is going to be the y coordinate of a concave up vertex. Now, we similarly have a maximum value. Maximum value. What is the highest value on a parabola? We look at maximum value when we're talking about a concave down parabola. Because, yeah, it goes down forever, but how high does it actually go? And it similarly will be at the vertex. It will be the y value of the vertex. So the maximum value, we look at that vertex, and that's at the point 3, 3. So the maximum value of that vertex would be 3. That is the highest y value it gets to.